Hello, everybody. So glad to be here and see you all, guys. My name is Denver, and I'm going to talk to you guys about RxJS. And this is going to be a bit more technical talks than the previous ones, so bear with me. So who am I? I'm basically, I work in a company called SailMove. Previously worked in Tartu University, Nortal, CGI. And I'm a real functional programming advocate. Wherever I go, I try to convince people that functional programming can actually be useful for you guys. And it's not something that only the math people do. It's actually something that can make your code simpler, more maintainable, etc. Also, I always must mention that I am a huge Dungeons & Dragons fan. So if any of you play Dungeons & Dragons, speak to me after, because I'm sure we have a lot to talk about. So this talk is about story, how we in SailMove basically solved big asynchronous problems and removed lots of ugly state machines from pretty much everywhere simply by starting to think differently about events. And SailMove application is very asynchronous. Basically, we have a very heavy front-end application in browser, which means that when all the assets are loaded and required and started, these are all very asynchronous operations. The application itself is something like a huge call center application and TeamViewer put into the browser. So there's lots of real-time communication between the people, and this really, well, since it's all real-time between different people, it's asynchronous by definition. So all this co-browsing, data access, everything is very asynchronous, and we kind of gotten quite good at solving asynchronous problems. So this is what asynchronous looks like. I mean, it's like this kid trying to catch this water, but the water is already gone. And I will say this is asynchronous in a nutshell. Most of you here are JavaScript developers, or at least have worked with JavaScript. So I'm sure we all have seen this callback hell where there's like lots of callbacks and it's very hard to reason about what happens. And callback themselves might not be the worst thing, but the bad thing is that there oftentimes also comes state with the callback. And it's really hard to track how the state flows through your application with all these different callbacks, because the state can change anywhere. You can't really control where can you change it. It's all over the place. Another thing is that we as a developers really like something called try-catch, because try-catch basically works with exceptions. And exceptions are great at handling errors. With callbacks, we don't have that luxury, because try-catch is basically not supported. It's not there. So you kind of have to figure out your own error handling, which usually is very brittle, breaks easily, hard to test, etc. Also, memory leaks. I on purpose added a memory leak on this slide. Basically, whenever you add an event listener and you don't clean up after it's used, you caused a memory leak. And when you have a single page application or a huge node application that has long running times, this can become a really big problem. And also, asynchronous programming basically always means race conditions. So there's lots of threats about race conditions, and very hard to manage them with callbacks. So does anybody know here what is reactive programming? There are a few. Nice. I've spoken to a lot of people here. Most of them don't know, but I'm glad at least some of you guys do. But I'm going to tell it to some other people, because it's actually an awesome thing. But it's hard to understand what reactive programming is. When I went to the World Wide Web to find out the definition, the place where all our knowledge is gathered, I found this image. There's like pull, push, some fancy icons. I mean, I don't know about you guys, but this doesn't really ring a bell for me. It doesn't explain what reactive programming is. So I went further. Reactive Manifesto, that surely must tell us something useful. So it's responsive, resilient, elastic, message-driven. There's these circles and everything. I mean, your project manager is probably going to be hyped when he sees this. But not sure if it will help you understand what reactive programming is. So we need to dig deeper. Microsoft, basically the guys who started out with reactive programming, or at least one of the main starters and drivers, they simply put it as observables, Linku, and schedulers. Now, if you're familiar with .NET technologies and work with them, then this might ring a bell for you. I personally stopped working with .NET technologies around 2 years ago, and it still doesn't really explain to me all this stuff, because I didn't really use everything that's written here. So let's go further. Stack Overflow has a huge post explaining, it's like 2 pages explaining what reactive programming is in really detailed, nice way. But the top comment to that basically sums it up. Please post it in English. Like, you're very smart, but if you're a beginner, then this simply doesn't make sense for you. So let's go further. When we look at the Rx API, then there's a method called FlatMapLatest, a very popular thing we use. An observable sequence which transforms the items emitted by an observable into observables and mirror those items emitted by the most recently transformed observable. Holy cow. I mean, if you understand this, then my speech is way below your level. I don't understand that, but I know, yeah. So this is my attempt at explaining to you guys what reactive programming is. And hopefully we can all learn from it, and you can all go home and start testing this stuff out and see that this is actually really awesome stuff. Reactive programming is basically programming with asynchronous streams. Asynchronous streams are mouse clicks, events. Does anybody else have any idea what might be asynchronous stream? Can you be louder? Keyboard input, that's correct. But we can go further. Eric Meyer, one of the founders of RX and creators, asked that, what is the difference between an array and an event? Any ideas? Fundamentally, they are both collections. The only difference being that event comes through time, while array is right there in front of you. So fundamentally, they are both collections, and you can treat them as collections. Now, if array and events are both collections, one is simply through time, other is just there, like immutable, then events, since we know that events are fundamentally collections, and events are asynchronous streams, we also know that everything can be composed of arrays, because you simply put items to an array, that's all you need to do, then it's composed of arrays. And the array is a collection, then when you start thinking about it, you understand that we can treat everything as a stream. And it's really hard to wrap your head around it, but once you get it, you get this Zen moment that, wow, everything is a stream. I just haven't noticed it before. So variables, user input, properties, caches, data structures, they can all be a stream. And when you have a Facebook scroll, you scroll down from Facebook and new stuff appears when you get to the bottom. That's just a stream of new information. That's all it is. Stream, everything is a stream, and you just have to figure it out, and then you get it to have this eureka moment. So let's build on top of that. Once we understand that everything is stream, and streams are collections, we know that arrays are actually quite cheap. So it turns out that streams are cheap. And this is where the functional magic kicks in, because you can take like multiple streams and merge them together. We all have merged arrays together, right? It's taking 2 arrays, putting together, or merging hash maps together. You can do the same with stream. You have 2 streams, and at the bottom, there is a third stream where the 2 streams have been merged together. These are values coming through time, but you merge them together as the values come. You can also like concat the streams together. So the first stream comes, it ends. Now the second stream comes, it ends. And when you concat together, it's same as string concating or array concating. Simply concating them together. And there are many other ways you can do as well. Streams are also functional. So everything you can do with an array, you can do with the stream. They can be mapped. I mean, we all know what mapping is, right? It's 2016. Even Java people know by now. So you just apply a function to every element in the array. You can do the same with streams. They can be filtered. So you can say that I'm only interested in the values that are higher than 10. So say you have a stream of numbers coming in. If the number is higher than 10, then you only take those to the second stream. They can be debounced, and this is really, really cool thing. It basically means you wait for a certain time period before you accept an element from that stream. So if there is no pause, like there is in the middle one, in the center, there are 4 elements in a row, then we don't take anything. But after that, there's a pause, and then we just take the last element. And this is really useful thing. Streams can also be completed, and this is also one of the fundamental things. Basically, when you have a stream, then you can take the first element of that stream into your second stream. And that's it. Now the stream is completed. Your first stream is completed, and I'm going to get back to it later, but what it means that because your stream is completed, you don't take anything else from it, you set it in the code, you only are interested in the first, that's it, then that means Rx knows how to clean up after you. Since your stream is completed, you don't need it anymore. Rx unsubscribes from everything, there's no memory leak, just magic. Same with take until. You can say that you have 2 streams. You take elements from the first stream, but if an element comes from second stream, then you stop. All the streams are completed. All are unsubscribed. No listeners are left over. And this is just the tip of the iceberg. There's lots and lots of stuff you can do with the streams. The Rx API is huge. And Rx is basically reactive extensions for JavaScript. This is what helps you do reactive programming in JavaScript. And it's not the only library out there, but it's what we found, and we found it to be the most useful for us. In Rx, streams are called observables because they are being observed. You observe a stream of elements, and you create observables. In this case, we create a string. Basically, it's a stream of 1 string, but the collection of 1 element is still a collection. So it's OK. Everything still applies. Even though if we ask what comes from this stream, just 1 element comes. But it's OK, because it's still a collection. Functions listening on events are called observers. So in this case, we create an observable, and we give an observer for it. And the observer has onNext, if new element comes, onError, if error happens, and onCompleted. This is when everything is cleaned up. And finally, you subscribe to observables to listen for events. And in this case, we simply subscribe to the response stream, and then whatever comes from it, we get into this function given to it. Now, some of you may have been listening to this and be like, I mean, Stenver, it's all cool, but asynchronous programming, we have promises. What are you talking about? I think there's even a speech about promises, so sorry. But promises are great. They're basically first-class asynchronous value, which means they are meant to be worked with asynchronously, and they are guaranteed to call 2 callbacks, fulfilled or rejected. And you can chain those fulfilled events together, creating a chain of promises, and it really helps to clean up your code. All the handlers are called asynchronously, and if the promise is settled, it will always return that value, which means that once you make a request to a server with a promise, if you call the 10 method again, it doesn't make a new request. It just returns the same value it got with the last request. If you want to have a new value, new request, then you just create a new promise. And that's it. It's very cool. In this case, for example, we could have something like this in TeamViewer. Like we could say that check for clickable elements, and we check if the element is actually clickable. If it is, then we send the click to the other side, to whoever we are paired in TeamViewer. But promises are not perfect. First of all, how do you cancel a promise? You can't. You basically need to figure out the logic how to cancel a promise yourself, and there are libraries that help you with it, but it's basically putting a huge bandage on a pretty big fundamental hole. And say you have a large image you're downloading with the promise, now you decide that user just clicks something else, he clicks cancel or does something else. He doesn't want the response anymore, he doesn't care, you can't cancel it, you just need to figure out yourself how to cancel it. In addition, what if you don't care about the return value? Say in our TeamViewer example, user actually did double click, so we don't care what the response to the first request was. So we only care about the latest request, so promises might expire before they're completed. Also, promises are meant for single values. If you want to return multiple values with promise, you can return an array, but it's basically just putting, again, working around a problem that wasn't meant to be solved with promises. Promises are meant to be worked with single values. Now, coming back to our Ajax example, we basically created a promise here. And this promise with this observer has all the components needed to be promise. And it turns out that if you think about it, then promise is simply an observable with single emitted value. And even though it only returns a single value, then a collection with one item is still a collection. So in essence, observables are promise plus plus. So if you believe in promises, then observables are at least as good as promises, because they have everything that the promise does, but they have then some. So we could rewrite this entire big block like that, just observable from promise. Rx is great at working together with promises. It's built to be worked with promises. So when we take a look at this Ajax request example, then we could treat the entire result as a collection, and this entire block could be rewritten into a much smaller one. Whatever comes back from this promise, we just map over the results. Even though there's only one value returned, we still map over it. Doesn't matter. And also, we can cancel the streams, because completing a stream means we don't care about whatever comes after the stream anymore. So whenever you complete the stream, you have canceled the stream. So the promises canceling problem is solved with observables. And now, I'm sure you all are tired of hearing me babbling about. Also, I've heard complaints that we want to see more code. So I'm going to show you some code. So let's say you have a stream of double-click events. And you have click events. You want to find out the double-click ones. So, and let's also say that if the user makes 3 or more clicks in a row, then those also count as double clicks. Now, how would you do that in a traditional stateful fashion? Any ideas? It will probably involve callbacks, state, set timeout, all the ugly stuff. And I'm not even sure how would you test that with unit tests. It seems to be a bane. Now, do you think observables will make this easier? This is what it would look like with observables. Basically, you just take a click stream, you buffer it, and you throttle it. So there needs to be at least 250 millisecond pause for you to accept the value from that stream. Then you take the length of every element from that buffering, and if it's more than 2, then you send it forward. If you like graphs more, then maybe this will help explain it. You have a buffer. We see that we buffer out only the clicks as collections, and after that we get the length of this collection, and we filter out all collections which are smaller than 2. What about memory leaks? Like, consider an example where you want to catch all the mouse moves, but whenever you do a click, then the capturing ends. In traditional way, this is how you will do it without causing a memory leak. You need to remove event listeners. In Rx way, you could do it like that. You listen for mouse moves, and then you go over every function, every element that comes from mouse move, and you log it out. When click happens, we listen also on click stream. We just take the first element, and then we dispose of it. Now, this might not look easier, because it's foreign syntax for many, and it's not really shorter. And you might also ask that, how do we clean up the click event listener? But it's completed, since we have the take one in there. Once it captures the take one, then the stream is completed, and Rx cleans up after you. And when we think about it, we could rewrite this entire thing like that. We listen for mouse moves, we take until we get the first click, and we just console log out all the results that we get. Everything is cleaned up after us. It's simple to read. It reads like a book. Very nice. Coming back to our first callback hell example, in here we try to prepare media and preload DOM in asynchronous way and just fire at the try start engagement method, hopefully that it will get through. It's complex, it's brittle, it's bad. In Rx, we could write the same thing like that. We start DOM preloader. We take until we get the hang up click, so this is a cancel basically. We combine this stream with another stream, and we map all the results into an object that has preloaded DOM and media. And later on, we subscribe to it. If it's success, we start. If it's an error, we cancel the engagement. A lot shorter, conciser, easier to maintain, and easier to test. I'm not going to get into testing in this speech, but Rx has excellent tools for synchronous testing. You can actually test your asynchronous code synchronously, but I'm going to leave this magic and discovery up to you guys. So in SailMove, everything is observables. Our app startup is with observables. The communication, we use observables everywhere. And honestly, I don't think we could make our application the way it is right now without observables. There will definitely be more bugs, more race conditions, and it wouldn't be as advanced as it is right now. And Rx is not only on JavaScript, so if there are any Java, .NET, Scala, etc. developers here, Rx is in there as well. Some of them are community-driven, others are officially driven. I know Java is made by Netflix mostly. And yeah, so it can be run on server as well, and we actually run it on server. In fact, most of our stuff starts as a stream on server. It's mapped or merged and filtered, and then sent to the client, where the client picks up the stream and just continues with it. So it's kind of like streams of beautiful data flowing through your application, and it's easy to understand where it goes, and it's very nice to maintain, and actually it's testable. And if you don't believe me, then lots of big players are using it. Angular 2 ships with Rx. React Redux mentions Rx all the time. Redux itself has actually written that it's basically Rx with the publish method. That's it. Cycle.js ships with Rx, and there are other frameworks as well. Netflix, Microsoft, Square, all of them are using Rx. And all the references or examples I took are in there. You can take a closer look. The first one is a nice tutorial, and I think we have some time for questions as well. That's what it says.
Oh, all right. I think we're actually
good.
Yeah, I think we are. Sorry, let me just triple check. Yeah, no, we're perfectly on time.
Nice.
Can we get is this on? Hello? There we go. Yeah, we're actually running eerily on time at the moment and don't have a ton of time for questions, but please come and talk to all of the speakers. We all kind of have this big yellow badge and have plenty of time to answer everything. But otherwise, thank you.
Thank you.